There we go. All right, so anyway, this chapter it goes pretty quickly, and I'm going to show you some skills. These are skills that you need to learn to go that next level in chemistry, okay? Knowing how to write formulas, very important, okay? But for a while, I'll write them for you. For a while, I'll write the formulas, and I'm going to show you how to classify them and balance them like that. That's our goal today. So, Todd, can you do me a favor? Hey, Todd, can you close that door? It's just a little bit loud. All right, so here we go. This is a chemical equation, and it actually is a way of chemists talking to each other and say, hey, zinc, and what's that little S stand for? Zinc as a solid reacts with hydrochloric acid, which is dissolved in, it's a solution, isn't it? If something's dissolved in water, it's a solution. And it's going to produce a zinc chloride, but you'll never see it. Why will you never see the zinc chloride? Because it's what? It's AQ. What's that mean? It's dissolved in water. You won't see it. And then you'll see bubbles. What do you mean? How do you know you're going to see bubbles? Because it says what after it? Gas. Everybody got it? Now, for example, we talked about this yesterday. What does this look like? And you say, well, every time I pour a salt shaker, that's what NaCl solid looks like, doesn't it? But what does NaCl AQ look like? What do you think? It looks like water. It actually looks like water, doesn't it? So that's why those little extra symbols are written just for extra information. Everybody get it? Like, for example, do you know what this looks like? Wait, what's the difference between AQ and L? What's the difference between AQ and L? Yeah, I mean, it could be liquid, I don't know, gasoline. It could be gasoline, couldn't it? That's a liquid. But what's AQ mean? Dissolved in water. See that? Okay. Now, real quick story. Anybody know what that looks like? I have a name for it, water vapor. I like the name. What's it look like? Anybody? What?
Can you not see it?
You can't see it. You're right. You can't see it. Now, I'll tell you a quick story, very quick story. If you took a big pot of water and turned on the stove, turned on high, eventually you'd see these bubbles. And it might bubble for an hour. It could boil for 2 hours. If you ever see anybody make soup and they leave it on the stove, it'll be boiling, okay? If I left that water in the stove for 2 hours, you see all these bubbles come out. You know, a lot of people don't know what those bubbles are. And so some of you think, oh, I remember a teacher one time told me that there's oxygen dissolved in the water. That's true. That is true. As a matter of fact, what do fish breathe? They don't breathe water. They let the water go past their gills, but what are they taking out of the water? Oxygen. They breathe oxygen that's dissolved in the water. If you put a fish in water that has no oxygen in it, it will die. It'll drown. Okay, now going back to my other story. There is oxygen, there is air and oxygen dissolved in water. Is that what I saw those bubbles? 2 hours of bubbles. Wow, if water had that much oxygen in it, why don't you just stick your head in it and start breathing?
Because we don't have the proper.
What now?
Because we don't have the proper way to extract the oxygen from the water.
If there was that much oxygen in there, I think we would. Now that's a good question. I've seen a mouse and they put it in super oxygenated water and it's breathing. So it actually could do that, but that's still not what the bubbles are. Anybody know what the bubbles are? It's this. It's that. Now, you can't see it. So you see a bubble coming up at you, right? But you can't actually see water vapor. And then when it comes up, it breaks the surface, and you see this little puffy cloud, don't you? And what has everybody in this room been taught to say when they see that puffy cloud? No, I don't think most people have been taught to say that. What do you see coming off the pan that looks like a cloud? What have you been taught to say? Steam. Isn't that it? Okay. Can I tell you something? You can't see steam.
Coming out of the
Now,
water.
you can't see steam, but everybody in here was taught when you see the little cloud to say steam. So here's what really happens. There is steam coming out right at the surface, and then that steam hits the cold air and turns back into a liquid. Little tiny, tiny droplets of water, and you can see them because they're liquid water. And what are clouds made of? Liquid water. Tiny droplets. Anyway, that has not too much about this chapter, but I do want to tell you that it's okay if you grow up and have kids and you see that stuff come off the pan, it's okay to tell them that it's steam. It's okay. It won't hurt anybody. It'll be all right. Actually, steam will hurt you. It's okay if you want to teach them that that's steam. That's fine. Anyway, let's go here. And what we found out was that we also, and this is a little bit higher level, chemists had tried to figure out why is it when I put this and this together, there is a reaction, and I put this and this, and there's no reaction. And that's really what chemistry is about, the study of why do you react, and what do you form, and why don't you react? And that's what chemistry is. So what we found out is chemists, just like humans, is this as far as we got yesterday? Because chemists are humans, when humans start to study something, they like to have some vocabulary words, and we did. And we know the reactants. Remember the reactants are on the left side here. These are reactants. And what are these called over here? Products. And what does that arrow mean? Produces, yields, makes, forms. Everybody get that? Okay, now, I'll show you something else I didn't teach you in other classes. You know the plus sign here means something different than the plus sign here? Huh. What? On the left side of the arrow, they haven't reacted yet, right? But you know what the plus says here? This reacts with this. This, if you add this and this together and they react, then you'll get this and this. So this says you're going to put them together to react. That plus sign here does not mean they're going to react. What does it mean here? If you let them react, what gets produced? This and that. See that? A little bit different there. All right. Now, the second thing humans do, besides having vocabulary words, they like to put them in categories. And every chemistry student knows how to do this. The first one we found out was one kind of reaction is called synthesis, where you take two simpler things and combine them into one thing. You see that? And that's called a synthesis reaction. And we took a look, and we said, yesterday we took a look, and we said, look, A plus B yields, there we go. That looks like synthesis, doesn't it? And then we saw number 6, is that right? All right, did we flip this over? Yes, we did. Okay, so we did synthesis, didn't we? And I'll bet the bell was about to ring when we did decomposition. Is that what happened? So what's the opposite of synthesis? Decomposition. That's where you take something that's maybe more complex and it breaks down into something that's simpler. But what I like about decomposition is one reactant. There's only one reactant in there. And so if you take a look here, you say, let's see, anybody over here? Anybody? No, I don't think so. You go over here and say, oh, look. See? This breaks up into this and this. This breaks up into this, and this. Wow, that's really some decomposition, isn't it? And then look at the number 9. This by itself, and usually you have to heat it. How do you tell? Wait, what do I have to do? Heat is not a reactant. Heat is not a product. So right on top of the arrow, don't I? If you heat this, it'll decompose into this and this. Okay, I got that. Let's go to the next one. Next one's called single replacement. Some books say single displacement. I don't know why. I like single replacement better, but you'll see me. It can be written either way. Single replacement, single displacement. Same thing. All right, watch. A plus BC. Here's an element plus a compound. And look what A did. A comes over and says, get out of here. I'm taking your place. B, get out of here. See how he kicked B out? Now B's all by himself now. And then A formed a compound with C. Oh, look at that. Everybody see that? So you have an element and a compound, and the element kicks out one of the elements and says, I'll take your place. Now here's a hard question. Hard question. Do you think A, in my example here, is A more likely to be a metal or a non-metal, and why? Now, if you can answer this question, you're up there. You're pretty sharp. In this equation right there, do you think A is more likely to be a metal or a non-metal, and why? Who wants to try? Nobody's raised their hand. You might as well take a chance. Nobody else has their hand up. Yeah, what do you think?
So like I would say A is more likely to be a metal because like if it forms a ionic bond, then like
Can I tell you, everything you said so far is really good. Oh, I didn't think you were going to stop. You start off so well.
yeah, no, I can't figure anything else out.
Okay, anybody else? Okay, think about this, all right? If this is an ionic compound, okay? When you write ionic compounds, who always gets written first? The positive ion, right? And in this case, it's going to be a metal. Now, if A kicks out B, why didn't we write it as Ca? Why do we write it AC? Right, so A must be a metal, and so what we know now is metals kick out what? Metals. Metals kick out metals, don't they? Now, look at this right here. Look at this one. And I know the person who typed this, I know her name, she was valedictorian and everything, but she did make a mistake on one of these, and I'll have to fix that one. But here, this is not a mistake. What's this? What's that? That's singular placement also? What's different about that?
D is a non-metal
How do you know that?
because it replaces C in the compound, and if it was a metal, it would be written as DB, but instead it's written as BD.
Very nice. That's exactly right. So in this case, who is D kicking out? It kicked out the non-metal, didn't it? And so it formed a compound BD and kicked the non-metal out. You see that? Very smart. Very good. Okay, now what do we do is let's go look for singular placements. Go find some. See any? Anybody? Raise your hand if you think you found one. Yes. Yes. Ding, 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 ding. All right. Who's kicking out who?
The metal is kicking out the non-metal.
Well, it's unfortunately, even though hydrogen is a non-metal, unfortunately, what is the charge of hydrogen in this compound? And so zinc is going to kick out the positive ion, even though hydrogen is a non-metal. Sorry. So it is going to kick hydrogen out and form a compound with chlorine. The biggest mistake the first-year chemistry students make is this. They think you simply take the zinc, kick out the H, put the H over here, and make ZnCl. They think it's just like cut and paste. Well, that's a problem, you see, because why do we spend a whole chapter learning how to write compounds if you think zinc forms a compound with chlorine like this? If you think that's zinc chloride, there's something wrong. It's not cut and paste. I just said zinc's going to form a compound with chlorine. How does he do it? Hang on. There you go. Ding, 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 ding. That's how you do it. And that's why it's written that way. See that? And now what about this? Well, you kicked hydrogen out. Why didn't you write just plain old H?
Because you have two fluorines, you'll need two of those HCl, so you have two hydrogens.
Well,
Also,
even though I'm going to teach how to balance today, let's assume you don't know about balancing, okay? Why would, yeah, go ahead, Claire.
Hydrogen is
It is. If you kick the element hydrogen out, it has to be diatomic. It has to wait till another one gets kicked out, doesn't it? Very good. And so that's why they wrote H2. So there's all little bit of tricks here. All right, any other singular replacements here? Singular replacements. All right, I'm going to show you a trick, okay? First of all, this one is. Now, I want you to try it. I'm going to tell you that number 9 is singular replacement. Now, you make it happen. What are you going to write on the right side of the arrow? What are you going to write on the right side of the arrow? You already done, Will? Try it. Write it down on paper and see if you get it.
Someone's saying
All right.
over the internet.
All right, go ahead. I'm listening, Will.
Oh no, I'm trying to figure.
Okay. All right. I want everybody to try it. It's okay to make mistakes. I'm fine with that. But I want you to try it. Okay. You got it, Lydia? You got it?
It said aluminum sulfate plus copper.
Okay. So you think the aluminum is going to kick out who?
The copper.
Okay. So let's put copper by itself. Is he diatomic? Is that a diatomic element? I'm gonna go back to Claire. Claire, how do you know how do you know if something's a diatomic element?
It either ends in GEN or iron.
The elements N and GEN, that's oxygen, hydrogen, and nitrogen. And what's the other ones?
And then they end in
INE, like chlorine, bromine, iodine, fluorine. All right, so is copper a diatomic element?
No.
No. So it's just copper, right? And what's the other thing?
Aluminum sulfate.
Okay, is it like that? If it was, everybody in the world would be a chemist. And you wouldn't have, everybody would have gotten a great grade on the last test. Is this how you make aluminum sulfate? What's the charge on aluminum?
It's not a plus 30.
Oh, what about sulfate?
Minus 2.
Yes? What are you going to do about that?
So you have to have 3 sulfates and 2
Ah, everybody see that? It's not cut and paste. You get it? It says aluminum is going to form a compound with sulfate the same way he did last chapter. Get it? Now, it should bother you because you notice that there were 2 aluminiums here and only 1. We're going to fix that. When we balance the equation, we'll fix it. But right now, this is the idea of what's going on. All right, let's try one more over here. See if there are any single replacements over here. Yes.
You said to tell you when it was 2:20.
Oh my golly. How can we be done already? That was really fast.
That's what you just told Thomas.
Okay. All right, let's do single replacement. Okay. All right, anyway, I guess we're going to stop. Short period.